Welcome back to another cheapo multimeter review. Yes, that's right. It is cheapo time in the nation. Today in the cheapo spotlight, the one, the only, the all-new WinAPEX ET8104. One of my favorite cheapos thus far was his little brother, the ET8101. How does this guy bode? Well, let's take a look and compare the two. In the box, we've got, well, in the box, here's the box. If you want to see that box, yeah, it is a typical standard. No frills box, and you get your set of test leads. Now these test leads I really like. They're not the standard cheapos that you see quite a bit. No, they're a step up again, and they have a Cat 3 rating, and they are 1000 volts max. Now I gotta say, yeah, they're not silicon, but you know what? They do feel really nice. They're fairly long, about 3 feet or so, 3.5 feet. The shrouds on the end, looking good. Nicely done, nice and shrouded. And the tips themselves, really sharp, really pointy. And you have that really nice thick finger guard protection here. So you really have a nice feeling with these probes when you're using them. So all in all, I gotta say, for the cheapo set of probes, hard to get much better than this. Are they any good at continuity? Well, we will soon find out. Also, you get a thermocouple because the 8104 does do temperature. And yeah, the last WinAPEX I had did not do temperature, so I made sure to get the latest model with the temp. Finally, you get your handheld multimeter booklet. It's really a few sheets of paper, gives you the specs, and nothing overly exciting, but hey, it does the job. I'm going to be bringing out the older, but still nonetheless quite capable ET8101 for a comparison during this review. Yeah, that is the last year's model. And once again, one of my favorite meters of 2018 in the cheapo round. I really love my WinAPEX ET8101. So we're going to be bringing him along for the show today. And if you look style-wise, really nothing has changed. Now, I did replace the standard black boot that came with this guy in favor of this magnetized orange one. Originally, it did ship with the exact same boot. The same quite capable tilt stand. I wish it was perhaps a little bit broader, but nonetheless, it really does do a fairly decent job at giving you a good stationary position to move that meter. For the sake of comparative purposes, I brought out the Habotest 118A over here on the right, and on the left, the Rich Meter's 403B. You can see the WinAPEX falls in between. Certainly not a small meter, and definitely not a big meter. And once again, if we're going to compare this size-wise to, I don't know, let's just move down the bench a little bit here. And if we put it up against, an older BK Precision, my 68. Oh, that big honkin' ET8181. I'm sorry, UT181A, UT195E. Yeah, so, you know, for me, you know, I still find this 191T here a really good-sized meter. Really probably my favorite in terms of overall size. I really love that 191T. And compared to that, it is a dwarf. But that's okay. I'm not dissing this because it's small. Just that some people might have a preference for a larger meter, especially if it's spending a lot of time on the bench. But in terms of portability, yeah, let's take a closer look at that selector switch. It starts off at the 9 o'clock position for the off. First in the line of fire is the frequency and volts AC, followed by volts DC, millivolts AC-DC, diode, continuity, resistance, and capacitance, frequency and duty cycle, high current amps AC-DC, milliamps AC-DC, temperature in both Celsius and Fahrenheit. Finally, the bottom of the list, NCV or non-contact voltage. As well at the top, you've got 4 soft button selector switches, starting with your select for the multiple control in terms of different select ranges. We have our hold/backlight, our range/rel switch, and finally the max-min, as well as a flashlight feature. After all, what would a cheapo be without a flashlight? At the bottom, we have the high current input. And in the middle, of course, we have our common. And on the right, we have our temperature, our voltage, resistance, frequency, diode, capacitance, and as well, that milliamp range is also being shared. It does not have that separate milliamp input. Finally, at the bottom right, you don't see this every day on your cheapo meters. Look at that maximum milliamp 999.9 milliamps. I think we're going to have to test that. We're going to turn it on now for the first time. Look at that gorgeous, absolutely gorgeous inverted LCD display. Wow, it is really nice. Now you're getting sort of a blue hue on the camera itself. In reality, it's actually more of just a nice subdued white ghostly look, but is really, really nice. So very easy on the eyes. Yeah, I really like these inverted LCDs. Very, very nice. With this type of display as well, you can see that viewing angle is really, really good. You really have a full spectrum. Doesn't really matter how you're looking at the meter. You're always seeing the display. Got a lot. If we bring out the Rich Meters 406B that I reviewed not too long ago, you look at that inverted LCD. It is almost as good as that Rich Meters. In person, it is just, I'd say, 10% less in terms of overall contrast and sharpness, but boy, it is awfully close to the Rich Meters. So great looking display. One thing I've noticed with the 8104 is that it does auto power off really quickly. Now it says 15 minutes in the manual, but in reality, it's more like, to me, 5. So a little on the quick side to auto turn off. Starting things off with our high precision voltage test. That's right, we're gonna look at 250 millivolts is what we wanna see. So let's put it into millivolt range. And here we go with the default probe. I really do like these probes that ships with. The last APEX 8101 shipped with the exact same probe. So I'm liking these a lot. Alrighty, here we go. 250 millivolts is what we wanna see. And already wanna see 250 millivolts. And look at that, spot on. Wow. Try it again. Spot on, and it's fast. Loving it. Next up, we want to see 2.5 volts. Here we go. 2.500, spot on, super fast. Oh, gosh. Loving it. Remember, this is a 10,000 count multimeter, so we're getting lots of resolution for our cheapo dollar. Already, Aphrodite, we've got 3 good-looking WinAPEX multimeters lined up for our DC Current Showdown, sitting at 322 millivolts, actually 321 according to the DC power supply. And right across the board, starting off the 8103 in the left, 8104, star of the show in the middle, and the 8101, last year's model on the far right. Here we go, 321, and look at that, spot on, 8101 and 8104. Let's take it up a notch, up to 1.2 volts, 1.24, 1.24, and 1.24. Doesn't get any closer than that. Here we go. Yeah, let's see some voltage. 5.4, actually 5.38 volts. 5.38 for the 8104, 5.39 for the 101, and 5.4 for the 103. Up and away. Let's go up to a whopping 11.4 volts now. 11.4, 11.4, 11.4 right across the board. Taking it up to 16.9 volts, 16.98, 16.99, and 17.0. Up to 25.9 volts. 25.9 all across the board. Wow, it is so close. Now we're going to max things out at 29.5 volts, 29.5, 5, 5, 6, 29.50, 29.50. Wow, that is super close. Loving it. Wow. So there you go. In terms of overall accuracy, they are pretty well neck and neck. Definitely not a winner. Hey, in this case, they're all winners. But God, look at that display in the middle. I really love that 8104 display. Looks awesome. Next up is resistance. Now I have a 100 mega ohm resistor here, and it did not show up on the WinAPEX, but as we can see, yeah, according to little uni-t here, whoopsie daisy. So just a tad too high for the WinAPEX to read, even though it does have that 100 mega ohm. Right, sitting at 9 mega ohm right now. Let's bring it down to 7 mega ohm. 5, 3, 1 mega ohm, 900 ohm, 800, 7, 500 ohm, 200 ohm, 100 ohm. Yeah, nice and fast. No worries there. Next up on the smaller side, we have got a 47 nanofarad. Let's check it out. Hey, close enough, 51. And here's a 4.3 nanofarad. Excellent. Yeah, I really like the speed at which that display moves. Very nice. Now, something else worth noting is that apparently it does have a backlight that you can turn off. So I'm going to just dim the lights. And let's disable that backlight. Here we go. And now it is off. Now, I don't know about you, but boy, it is really hard to see. Let's just see if I can measure something here. Yeah, so it's still, I mean, wow, it's really hard to read. I don't know, when you would really want to disable that backlight, but anyway, there you go. You do have the option to disable it if you so desire. Diode mode it is. Here we go, starting off the green LED. It is lit up and forward voltage drop, 1.8 volts. Here's the yellow, looking good. Over to the red, shouldn't be any problems there, and no, none whatsoever. Over to the blue, lights it up, gives us that forward voltage drop. Finally, the white, so bright, and yeah, do we have that forward voltage drop? Yes, we do. Hey, 5 for 5. Yeah, I wasn't really expecting anything less than that. Good job, Apex. Yes, oh yes, it's continuity time, baby. Here we go. Stay tuned. Don't be shy. A 1 and a 2 and a... Oh, yeah. Nice, nice, nice and loud. Tad, perhaps just a tad slow in the latching department. But barely. I mean, that is quite acceptable and looking good. Probe Masters, you knew that was coming. Here we go. Oh, yeah. Can't do much better than that. Loud latched and oh so cool. Well, hot. I mean, it's good. You know what I mean. Maximum volume output in decibel mode is 69.6 decibels. Alright, got it hooked up now to the function waveform generator. Sitting at 1.1 megahertz, 500 millivolts, peak to peak is the amplitude. And let's take it up. Now this does have a 10 megahertz cap, so let's see if we can get there without any issues. Here we go, up to 2.1 megahertz, looking good. 3, 4, 5, 6, 7, up to 9.1 megahertz, looking good. Bring it up, 9.5 megahertz, and it's just starting to fall off just a little bit, 9.7 megahertz, and it looks like we've lost it. Bring it back down to 9.5 megahertz, 9.4. All right, so it looks like around 9.4 megahertz is about it. Let's try a little bit more here. No, so it's given up after 9.4 megahertz, so just a wee bit short of that 10 megahertz cap that it advertises. One annoying feature thus far is that even with the auto power off enabled, it still will shut itself down. Yeah, that is just definitely a real PIA. And I'm not talking about Boker chip. Right now we're sitting at 539 amps. Remember, this has a basically 1 amp fused on the milliamp range. They're saying 999.9 milliamps. All right, well, let's check it out. So we are going to bring it up. And went over. That was pretty fast. Here we go. Yeah, unfortunately, I blew that milliamp fuse. Look at that. Oh, God. So I'll have to replace that. I got a little too excited, carried away. with the milliamp testing. So let's fix that and we'll get back into the milliamp. Interesting enough, they have put in a 630 milliamp glass fuse on a meter that's rated for 999 milliamps, and it says fuse. So they're giving you the wrong rating. That is a big, nasty Not happy with that, WinAPEX. If you're going to give us a 999 milliamp rating, then put in at least a 1 amp fuse. Ah, gosh. All right, I've got my fuse box out here and trying to see if I have something close. No, not a pigtail. Lots of pigtails. Go figure. I've got these 10 by 38s, but that is just going to be way too big. Yeah, definitely not going to work. No, too bad. Okay, let's see. What else do we have here? Looks like it's time to order fuses. So I've decided I'm going to go ahead and replace this fuse assembly altogether. I'm going to put in one of these poly-style fuses, the self-resetting ones. This is rated at 650 milliamps, and I'm really not going to be using this for anything higher than that milliamp-wise, so that will suffice and prevent me from having to replace that next time I decide to blow it. Alrighty, time to get down and dirty with a little bit of soldering here, and let's see if we can make this guy a little more serviceable, the milliamp range. Alrighty, so the transplant is complete, and we now have that poly-resettable fuse inside, replacing that nasty, low-rated glass fuse. Now this is a 600 or 650, I believe, poly fuse. Let's see, going up to 400 milliamps, and 400, 560, 550, 650, and we're getting that over amp warning. Bring it back down. Take it up to around 600. Yeah, so this is probably a 600 milliamp polystyle fuse, and definitely a lot better than that 630 milliamp, which was getting blown all the time. So there you have it. Really nice feature is the temperature mode that ships with the 104. Now, as you can see, it has that onboard sensor. So without utilizing that thermal probe, you can still have your ambient temperature in both Celsius as well as Fahrenheit. Now, there's no dual display, nothing fancy like that, but it's nice to have both of those temperature readings available. And of course, you can utilize the thermocouple that it ships with. If you want to get another temperature, I'll just squeeze it with my fingers. And wow, look at the heat just radiating out of me. 91 degrees, 92 degrees Fahrenheit. I am burning up, folks. It's because I love these multimeters. All right, cool. Well, no, it's actually kind of hot. Next up is contact voltage mode. You can see I've got that rotary selector in the NCV mode. And what that means is we're going to be able to detect voltage. Well, you know what that means. You've seen enough of my videos, right? Yeah. So how does it work? Simple as that. In this case, I do not have to hold down on any button to get that NCV activated. Next up is high voltage mode. Let's bring it up to 1000 volts DC and see if she survives. Here we go. 3, 2, 1. And it's climbing. Almost 1000 volts. Here we go. And we have an audible as well as, well, no, we strictly have an audible detection. Let's bring it down. Bring it up again. And once again, we have that audible alert. There is no visible detection whatsoever. No LED on this cheapo meter. Too bad. It's really nice when they utilize both the audio and visual indicators when it comes to things like voltage alerts, what have you. But there you have it. Seems to have survived that spike. Good stuff. Starting off with the jack inserts, they have your standard metal filament, and they seem to be soldered in there fairly good. The solder's gone right through the PCB, so no half-ass jobs in that respect. Now, speaking of half-ass jobs, though, look at that 600 milliamp, 250 volts. That was the rating, And yeah, they're showing us 1000 milliamps on the other side. So shame on you, WinAPEX. I've replaced it temporarily with this resettable polyfuse. When I can find a 1000 volt fuse, I will probably utilize that instead. But there it is. Now, I did verify this is a 1 amp fuse on the high current side. Once again, it's rated at 250 volts. So, anyway. Starting at the top, we have one lonely PTC on the voltage side of things. That's it. That's all. There's our speaker, and we have one electrolytic cap as well. There's the LED for the flashlight. And you can see here is where they've utilized the NCV. Once again, it is embedded into the PCB itself. Less effective and generally not a great idea when it comes to non-contact voltage detection. It really is beneficial when you have a protruding or extruding. Here's the reverse side of the PCB. As you can see, oh, kind of sloppy. Yeah, we got a lot of flux residue and just overall crudiness going on there. Not liking what I see. And yeah, take a look at those input jacks on this side. I take it back. They're not that super duper after all. Yeah, we've got one here at the top. They're not so bad. That's on our high current side. But that ground, that common there, look at that. Yeah, solder didn't even go all the way through. Not liking it. And once again, wow, a lot of flux there. So, you know, if you can, get in there with a Q-tip and some ICP and clean that sucker. There's our tiny little current shunt. Rotary selector tracks themselves look to be gold-plated. Nice and clean in that respect. There's our soft touch. And finally, the inverted LCD display. And if we lift it up a bit, we can see there is our IC cobbed in all its goodness. And finally, here we have the EEPROM starting off with the data for the IC. Well, as you can see, once again, a little sloppy in terms of the overall fit and finish here. A little on the dirty side. Not liking it at all. All right, gonna put things back together and closing thoughts on the WinAPEX ET8104. Oh, wow. You know what? I am dissatisfied. Yes, I had big hopes for this guy, especially after the great performance and build quality of his younger brother. No, this was a disappointment. It failed at that 10 megahertz rating, reaching only around 9.4 megahertz. Not acceptable. If you're going to label it as 10 megahertz, then make it do 10. And I got to tell you, it had that annoying shutdown bug all the time. Beep, 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 beep. Oh my God. Worse than my mother-in-law. Yes, it drove me crazy. Mislabeling that milliamp fuse. Hey, come on, you're rating at 999.9 milliamp. That's what you say, then that's what you gotta give us. Don't be sticking a 600 milliamp fuse in a 999 milliamp rated multimeter. It's just bad business. Build quality inside was sloppy, a lot of flux, a lot of mess, and generally done on the cheap side. Gotta love that great clear vibrant display, 10,000 count true RMS, that's always a good thing. Yeah, it had some great advertised ranges, 100 mega ohm on the resistance, 100 millifarad on the capacitance, that is a bonus. Finally, it was accurate and fast to settle. But you know what, I still can't get over those annoying other things. For me, it's just wrong, and it's leaving a bad taste in my mouth. The WinAPEX ET8104 gets a very disappointing 2 out of 5 stars. Thanks for watching this review, everybody. Don't forget that Halloween special coming up October 31st. Stay tuned for that. And I've got some other great reviews coming up, including that AU4748++ desoldering station. That's going to be a good one. Thanks for watching. Till the next time, keep on testing. According to the user manual, 2.3 volts is the magic number for that display to keep on displaying. Is it true? Do we believe everything we read? Well, let's find out. Here we go. We're going to start adjusting that voltage. Wow, 2.5, and it's already pretty dark. So, yeah, 2.6, 2.7, 2.8, it's okay. 2.6, it's still okay, but it is definitely getting dark. And 2.4, no can do. 2.5, let's see. Not really. So I'm going to say 2.6 is really the magic number for usability in terms of the display. Not 2.3 as the manual stipulates. So there you go, guys. don't believe everything you read.